Okay, here we are. I'm going over these pushdown automata because I'm not sure we have time to do it at the beginning of class. Here we have a language, a to the I, B to the J, C to the K, where I, J, and K are all greater than or equal to 0, but I equals J or I equals K. So in other words, take a string consisting of some number of A's followed by some number of B's followed by some number of C's, and the language is a language in which every string has either the same number of A's as B's or the same number of A's as C's. Okay, this language is not regular. You could prove that with the pumping lemma. But instead we will just come up with a pushdown automaton which recognizes all and only the strings of this language, or I should say accepts all and only the strings of this language. So recognizes this language. What should we do? Well, the hint, as I mentioned in the assignment, is to use non-determinism to guess whether it's the B's or the C's that will have the same number of A's. Whether it's the B's or the C's that have that we have that sort of match the A's. Okay, so let's go. Just like in class, we have this start state, which should be an accept state because the empty string is the string of this language. And then the very first thing we want to do is to push something onto the stack. So we make a rule, lambda goes to pound, which means you should read no character, pop nothing from the stack, but push a pound sign to the stack. Okay, and here we are in state Q2, which is intuitively the state in which we read through the number of A's. And we have to remember the number of A's because there have to be either that number of B's or that number of C's. All right, so we chill in state Q2 reading A's, and every time we read an A from the string, we pop nothing from the stack and we push onto the stack an alpha, which is a special stack character that corresponds to the existence of an A. But of course I don't know how many A's there are going to be. So I stay here following the A's, but if something else besides an A should appear, then I have to do something for that as well. Well, the way we do it is we say, okay, on the one hand, suppose it's the number of B's that match the number of A's. Well, then what I want to do is at every moment just guess that the A subpart of the string is done. And so what I want to do is sort of non-deterministically go to this state Q3, the state in which we read all the B's. And so now this sort of says like, yo, at any moment, guess that like B's are happening. See if I'm doing this right. Yeah, and then at stage Q3, I read the number of B's. But this is like the path that's consistent with there being the same number of B's as A's. So here, what I want to do is to go through in Q3 reading B's, and every time I read a B, I want to pop an alpha from the stack and push nothing. And what we hope will happen is that I get to the end of the B's and I go to some state, well, I've called it Q5 here on my paper, so let me do that. But in order to get there, I read nothing, push, or rather pop the pound sign, push nothing. And here I just chill because the number of C's is irrelevant. So I read C's, push, or pop nothing, push nothing. Okay, so what I hope to now convince you that certain strings with the same number of A's as B's will work. So for example, I don't know, A cubed, B cubed, C squared, for example, is a string of this language. I will show you how it will end up in this accept state. Well, first we push this pound sign to the stack, we end up here. We stay in state Q2, reading 3 A's and pushing 3 alphas onto the stack. Then we non-deterministically go to state Q3, and in state Q3, we read the 3 B's, popping every time we see a B an alpha from the stack, so therefore we keep doing that. And in this state, I then, if hopefully the bees all get used, and if they do, if all the bees do get used exactly, then there should be a pound sign just sitting there, and I pop that pound sign, and I go to Q5, and now the number of C's is irrelevant. Now, if there were not enough bees, then I would die here in Q3, if there were only 2 bees, for example, because I have no rule for what to do when I'm in state Q3 and the next character is a C, for example. Because I only get to go to the state of I'm ready to read the C nows after I've popped that pound sign off the stack. But I only get to pop the pound sign off the stack if there are precisely the correct number of bees here. If there are, what did I just say? If there are not enough bees, if there are not enough bees to pop all the alphas off the stack, then I can't ever leave this state. I die in Q3 because I still have a B to read, but there's no rule for what to do when I'm in state Q3 and I have a B and I have a pound sign here. And if there are too many Bs, then I go to Q5, but then I die in Q5 trying to read Bs, and there's no rule for what to do when there are Bs. Okay, but of course, what if instead it's the number of C's that equals the number of A's? So that would be a string like, I don't know, A cubed, B squared, C cubed. Well, I need to account for that as well. And so the sort of brilliant move is that in Q2, oh, I think I should have also mentioned that at every single stage back in Q2, as I'm reading new A's, I never know what's going to come next. So I sort of automatically go to this state. But if there were A's left, then that path dies. Okay. But I'm also, at the same time, there's sort of like 3 levels of non-determinism here. At the same time, I'm going to sort of non-deterministically shift to the state Q4, which provides a path for there to be the same number of A's as C's. And in state Q4, we first process the number of B's that there are, if any. So B's, if a B is encountered, I really shouldn't do anything with respect to the stack. Don't pop anything from the stack and don't push anything to the stack either. And then eventually, out of this, I non-deterministically go to the state where I'm ready to read and process the C's. And now here, every time I read a C character, I should pop an alpha from the stack and push nothing. And hopefully, if we do it completely correctly, we'll end up in a state Q7, and the only way to get to that state Q7 is if the number of C's exactly matches the number of A's, so that what we're left with is just a pound sign on the stack. And again, if there are too many C's, then I end up in Q7, but I have C's left to read, so I die there. And if there are not enough C's, then I can't ever get out of state Q6, because the only way to get out of state Q6 is to pop a pound off the stack, but the only way for there to be a pound on the stack is if there were enough C's to have popped all the alphas off the stack. Woo! That was pretty hard, but that makes complete sense to me. Hopefully that explanation was good, was a good one. Okay, we got 4 minutes. I may or may not finish this video, so I might stop abruptly if the bell rings. Got to go teach calculus in a second. Here we have what I think is maybe a harder language, which is the language of all palindromes. So anything of the form like, you know, A, B, B, A, for example, or A, B, B, A. Okay, this is hard because I have to account not just for these, but also A, B, A counts as a palindrome, or A, B, A. And so there's this sort of symmetry with respect to either the sort of middle letter or it's sort of different whether there's an odd or an even number of them. All right, I need to accept these. And of course, what I have to do, loosely speaking, I think this is not so hard, I have to kind of push everything onto the stack, and then in the second half of as the string is processed, pop the same number of things back off again. But I never know when I am at the middle. All right, so let's begin. I'll at least just give the answer, and then I'll give the explanation. I start in Q1, that should be an except state because the empty string is a palindrome. Once again, I'll push onto the stack a special stack character pound so I know when I'm on the bottom of the stack. State Q2 is intuitively the state of processing the initial first half of the string. And so I stay in Q2, and every time I see an A, I push an alpha to the stack. And every time I see a B, I push a beta to the stack. But at the same time that is happening, I divide my machine up into many, many different copies of itself. At every moment, guessing whether perhaps I have just read, perhaps I am at the middle. And I go to state Q3, which is the state of processing the second half of the string and checking that it works. So I want to, one, I want to be able to just go there. Two, I want to be able to go there by reading an A. And these three rules capture the fact that, like, when I hit the midpoint or something like that, this is consistent with there being an even number of characters. So I hit the first n of the two n characters and now go immediately to process the second half. But these two rules are consistent with the fact that they're an odd number of characters. So I did the first half, and then this is the middle character, and now I go to process the second half. And what happens in state Q3 is I just do it all in reverse. Every time I see an A, I should pop an alpha, push nothing. And every time I see a B, I should pop a beta and push nothing. And sort of the stack is perfectly suited to check whether something is a palindrome because it's just kind of coming, whatever. All right, and finally, if it all works out perfectly, I go to the except state Q4, and the only way to get to that except state should be if there was a pound sign only left on the stack. And what I encourage you to do, if you got this exact same thing, great. If you don't get this, think through a couple more, maybe do some test cases, right? Go through some test strings just to see how this machine works. Check how this string is processed. Check how this string is processed. And then try some non-examples, like A, B, B, A, or something like that, and see how that string is processed and find exactly sort of where in the machine that it dies to convince yourself that this is the correct machine. Okay, hopefully that was helpful. I'm going to upload this video and send it right now so you can watch it tonight so we can start the test right at the beginning of class. Cool, bye.